The idea here is to keep the context. When you are converting words into numbers, do not convert them randomly, but while you are making this conversion, keep the context in mind. Bring the context in between while you are converting words to numbers. Okay, so J.R. Firth in 1957, he told that you shall know a word by the company it keeps. What he's trying to say is context. If you give me context, then you will get to know the true meaning of the word. Okay. King, strong man. Basically, king is a strong man. Is a stop word. We have removed it. A is a stop word. We have removed it. So, king, strong man. Okay. Here, if we take context, simply context means a window of words. Okay. Let's say if I take context window as size is 3. Context window size is 3. Then what I'll do is this will be the word, or here let me put simply 2. Here we have only 2 other words. This is the word, and this will be the context window. King is in which context? Tell me. King is in the context of strong and man. Now if you come to strong, you have some words before it, some words after this. Take 2 words here, take 2 words here. Tell me strong is in which context? Tell me strong is in which context? Context means words only, like a window of words. 2 words here, 2 words here. Strong is in which context then? Tell me. King is in the context of strong. So king as word, and this is a context, strong. King is another word, like the same word, which is also in the context of man. If I take context window as 2. Now if I say strong, if I take 2 words here, I don't know the word here, but at least I can say strong is in the context of man. Strong is also in the context of king. Now the last one. Tell me what is the context of man here? What is the context of man? 2 words here, 2 words here. Man is in the context of king. Man is also in the context of strong. So first, what we are going to prepare here is, we will take the word, take the window. Here window size is 2, which is the context window size. So king is the word, and the context here is strong. King is the word, context here is man. Strong is the word, context is king. Context is man. Basically, context means what? Surrounding words. Man, the surrounding words are king and strong. If it is a larger, longer sentence, maybe man will be in 2 more words also will come here. Okay. Now, this is the data that we are going to create. We will browse through the whole data set and create this word and context data. Okay. What are we going to do is, we are going to create this data set where we will call this as input, and this is the output. What is the output? Output is the context, input is the word. Then somehow try to match them, or somehow try to tie them. That means when you are converting words into numbers, you're going to somehow bring in the context into the picture. So here is the idea. First, create the training samples. What are the training samples? Put the word here and put the context here. Then build a model to convert these words into numbers. Let us see the overall process. Okay. What is the first step? Create the input output data pairs. Input is word, simple word. Output is word in the context. King, strong man. Strong, king, man. Similarly, what about this queen? Queen is in the context of wise. Queen is also in the context of woman. Wise in the context of queen and woman. Woman is in the context of queen and wise. Like this, you go through the whole data set, create input and output pairs. Input is the original word, output is the context word, word in the context window. The next step, build a neural network model by taking this input and this output. You have this input and this output. You build a neural network model. What is the idea behind neural network model? What is the major objective? If king is connected to strong, when the input is king, the output is man. When the input is queen, output is woman. It never happened that when the input is queen, output was never man. Maybe similar words that are connected to words in the context will get similar numbers. Similar words that are not connected to this context, they will never get those numbers. The weights will be automatically adjusted that way. So what is the overall process here? Input is your word, output is the context. Build a neural network model and let it be shallow neural network. What is a shallow neural network? Do you remember the shallow neural network? A neural network that has only single hidden layer is your shallow neural network. Okay. So specifically build a shallow neural network, and you can give how many ever nodes that you want in this shallow neural network's hidden layer, and this will be your output representation for each of these words. So take the word as the input, take the context as the output. Here you build a neural network model, and the result that you get from the hidden layer output, that will be the numerical representation of each word here. The numerical representation of each word will be the result of the hidden layer output. That will be, let's say, for king later on, for king, the later on the numbers will be, let's say, 1.0298, 3.268, and then 4.1. For queen, the representation will be, since there are three nodes here, for queen, the representation will be minus 1.96, minus 2.38, minus 4.8, like that. Maybe wise and woman will have similar representation, and strong and man will have similar representation when you are building a neural network like this. That is the whole gist of word-to-vec. This is called a vector. A word has been represented like a vector. So there are two critical steps. Take the data, slightly clean it, take all the words, and then take the whole data as it is. Do not take the bag of words. You take each word and its context. Let the word be input, let the context be output. Then build a neural network model. The result of the neural network model will be the vector representation of the data. So these are the words. Now you can one hot embed them. You can do one hot encoding to build this neural network model. Go ahead, do one hot encoding, then solve it. But anyway, you're not going to take those one hot encoding values. You are not interested in that. You are interested in the hidden layer output. So convert word into one hot encoding, convert context into one hot encoding, get the output. These are known as embeddings, K embeddings. You can also say that I can have 4 hidden nodes. Then this will have 4 values. Each vector will be represented with 4 values. Okay, this is an n by n matrix, this is n by k matrix, and 4 will be your number of here 3 will be the number of values. Every word will be represented with a vector of 3 values. Okay, right. This is the final result. The final result of Word-to-Vec is the hidden layer output. You will be surprised to know the results. Like there will be even hidden relations that will be caught, because somehow when you are converting words into numbers, you have somehow tied them to context. So if king is connected to strong, if king is connected to man, similarly man is connected to strong, man is connected to king, then maybe the representation, the weights corresponding to king, the weights corresponding to man will be in such a way that they are somewhat similar. Queen has been never connected to strong, queen has been never connected to man. Maybe the weights that are related to queen will be largely defined by these values. Weights related to king will be largely defined by certain values. Those weights are automatically adjusted. You will get much more meaningful representations. Here is the result of the Word-to-Vec. This will appear like this. You supply king later on, which is one hot encoded value, then you will get these three values. So this is a king representation. This is man representation, strong, queen, and woman. Just by looking at these numbers, it will be difficult for us whether they are similar or dissimilar. We cannot say that. When the data set is large, we will be able to find out that this king and this queen, their similarity is very, very less. In fact, since this is three-dimensional data, we can take it as x-axis, we can take it as y-axis, we can take it as z-axis, we can even draw it and check like on x-axis, y-axis, z-axis. You will see that your king, man, you're strong, this will be near to one place. Your queen, your wise, woman, they will be at another place. Remaining words will be at another place. We can easily see that as well. Okay. So what is the major idea behind this? Words which are there in the similar context will get similar numbers. That works. Words that are not in that context, outside that context, they'll get different numbers. Here is a representation. If you put all these values as points, three-dimensional points, you have girl here, boy here, queen here, woman here, princess here, wise, pretty, good, man, prince, strong, king. Since we are drawing three-dimensional data on two dimensions, it will be very difficult for us to visualize it. The third dimension is still difficult to visualize, but if you look at it carefully, then we can find out that, these words are nearby one place, these words are in one cluster, these words are in another cluster. If it is beyond three dimensions, if we have four dimensions here, we can't even draw that. We just have to see and assume that these values are nearby. We cannot even draw it. Okay, if we have four values, or if we have four in here, same way, like this is a hidden layer with 4 or 5 or 6 hidden nodes, we will get the numerical representation. You just supply king here, you will get the 4 or 5 or 6, how many ever hidden nodes we have given, we will get the result. So basically in the result we will have another 2 or 3 more depending on the number of hidden nodes that you have given here. Okay, but difficult to draw. Yeah. In reality, do we give 3 or 4 or 5? In reality, we have to give it slightly higher, 15 or 20 or 30 or 100, depending on the corpus, depending on the distinct words that we have, because we have to give enough chance for all the words to be represented distinctly, and the word relation is preserved. Okay. So we can simply see that here we can somehow see that a particular type of words are falling in one particular place, particular type of words are falling in particular place. Not only that, it will even give you some, what do you call, surprising results. Look at this. I have a king vector, which is a numerical value. I can subtract man vector from there, because king minus man in text it is not possible, but king is three numbers here for you, 1 2 3 numbers, man is three numbers here, king minus man, you can do this math, isn't it? That will give you three numbers here. Can you add woman to that? Yes, you can add woman to that. Can you add wise to that? Yes, you can add wise to that. Can somebody make a guess if I calculate this? King minus man plus woman plus wise. This will give me a vector. Can you tell me where it will fall? Will it fall in red? Will it fall here? Or will it fall here? If I make this calculation, that's a abstract vector. Okay. We don't know the name of it, but where it will fall, make a guess. If I take king, if I remove man, if I add woman, if I add wise, where it will fall? Try to think about it. Will it be towards red, or will it be towards green or the blue? You took king. From king, if you remove man, and if you add woman, if you add wise, if you look at it carefully, you will get to know that it has to be red, isn't it? It has to be somewhere here or here, because you are adding all the queen elements, you are removing all the king elements. Man element has been removed. If you add woman elements, then it will be falling here. And to your surprise, you can take king, you can take man, strong, queen, and all that. King minus man plus woman plus vice. This is a new vector. When you draw this vector, it falls here. These kind of mathematics also taken care of. Check this out. That is the Word-to-Vec, a simple trick of ANN on top of your words. When you are converting words to numbers, we are converting in the most smartest way. This is one of the strongest method that is available, and it's kind of very simple but very effective. Any questions on this?